Hello, everyone, and thank you so much for attending this session at the PASS Virtual Summit 2020. It's a privilege to be able to present to you today. I've been speaking at PASS Summit over the years for several years and really enjoy the PASS community. I'm joining you from my home office here in Ridgefield, Washington. And as you can see, I'm proudly wearing my PASS Virtual Summit 2020 shirt here. I was just so proud to have this shirt. It's a speaker on it, and I was just downstairs, and my oldest daughter came in. She was just visiting, and she said, "Dad, I love your shirt. It looks great. You look like Barney the dinosaur." And it just really burst my bubble. But thank you so much for coming. My session today is titled Data Modeling Solutions for Challenging Data Modeling Problems. And I'll add with Power BI. We're going to be working in Power BI Desktop, and this is all about Power BI data modeling. But this also applies equally to Analysis Services Tabular. My name is Paul Turley. I'm a business intelligence solution architect and lead consultant with 3Cloud Solutions. You may know us previously as Pragmatic Works. We're now a larger team, but it's the same great people. I'm still working with the same great Pragmatic Works family at 3Cloud Solutions. And we focus on business intelligence. As a larger company, we are all across the entire Azure platform in the cloud. This session really covers everywhere from beginner to intermediate, a little bit of advanced information. If you're new to Power BI, then this session should give you some direction and should give you some food for thought and things to think about as you continue your journey with Power BI. But if you're an experienced Power BI and perhaps an analysis services business intelligence practitioner, then this session is for you. And we're going to get into the weeds and talk about data modeling patterns and show you some new things as well. Please check out everything that PASS has to offer. PASS, the Professional Association for SQL Server, have been leading this community for a very long time. We have a lot of volunteers and leaders and folks within the community who have been part of PASS for a very long time. I've been involved with PASS for about 15 years now. And the PASS Summit is just where it begins. User groups, online events, SQL Saturdays, training. PASS has a lot to offer. So go to pass.org and check out a lot of these offerings. If you're not a member of a local user group, and we get back to local meetings, then please find your local chapter of PASS. There are PASS chapters in most large cities and most regions throughout the world. And of course, there are online user groups that you can join. And we also have events like SQL Saturday. If you haven't been to a SQL Saturday in the past, know that these are a great opportunity for a full day of free training, to be involved and to begin your speaking career, to volunteer, to be involved in leadership. A lot of great opportunities. And of course, this year, a lot of the SQL Saturdays and other events have been virtual. And so we have the opportunity to work with folks from different time zones, different countries and cultures, and we all get to get up early in the morning and stay up late and be part of these great events. The PASS Marathon, virtual groups I mentioned, and lots of opportunities for you to volunteer and be involved and support the community, as well as take advantage of the volunteer efforts of many people in the data platform space. So get involved with PASS and get involved in the data platform organization. There will be an evaluation that you can fill out. You're encouraged to evaluate all of the sessions, and there's some great perks to incent you to do that as well. So please check that out. Get that done by November 20th. So I'm a member of the Microsoft Most Valuable Professional organization. I've been doing that for about 11 years. It gives me the opportunity to provide feedback to Microsoft and to be able to interface with product groups and leaders at Microsoft and really kind of be involved in the community. This is an organization of professionals, many of which are speaking at Past Summit this week, who both share their expertise and insights, but also will take feedback back to the product teams at Microsoft and help us work together to continue this journey of great products and services. You're welcome to reach out to me through LinkedIn, through Twitter, and through my blog. I usually share my information through my blog first at presentations such as this. So please check out my blog, follow my blog. You can provide feedback and comments, and then reach out to me through the social media channels as well. So what are we talking about? Well, we're going to talk about common data modeling patterns in Power BI. And we're going to talk about some of the gotchas that you might have encountered if you're just getting started and if you're in self-service mode. But let's learn from the successes of others and talk about patterns that we've been using for years and years with products that came before Power BI and modern data modeling techniques that we can apply within a modern tool, the Power BI platform. All right, but this is what we're going to talk about during this 75-minute session. We'll start with modeling schemas, different ways that you can approach crafting data into a model through different schema approaches, depending on your needs. But then we're going to focus on dimensional modeling, and we'll talk about where that came from, why it exists, why it's important, and the tenets of dimensional modeling, when you can kind of bend those rules a little bit and when it makes sense to strictly adhere to the tenets and the rules and the patterns of dimensional modeling. Within that space, we'll talk about role-playing, specifically role-playing dimension. We'll talk about bidirectional relationships, when to use them, when to avoid them, many-to-many patterns, when to use disconnected tables, and I'll show you some specific examples of using disconnected tables. And then this presentation borders on DAX calculation techniques. It's really hard to talk about data modeling without talking about DAX. It's hard to write calculations if you haven't modeled your data correctly. So those are two things that go together. And then we'll talk about some of the external tools that are available for you to use aside from Power BI Desktop, and how that can enhance your experience and be able to light up and enable more capabilities and to do things more easily than you might be able to do in Power BI Desktop. Then we're going to talk about composite models, both those that exist today and the next generation of composite model capabilities that we're going to see in the coming months and year within the Power BI platform. Pretty exciting stuff. All right. So categorically, there are really a few different ways that you can approach modeling data in Power BI and related technologies. Now, when I talk about related technologies, Power BI at its core implements the Vertipack tabular modeling engine, which was introduced with SQL Server Analysis Services Tabular circa 2012. Now, first we had Power Pivot. Power Pivot was introduced as an extension to Excel, and that was in 2010-ish. And then that same technology was introduced in SQL Server Analysis Services as tabular models, and it grew up pretty quickly. And as quickly kind of displaced the multidimensional technology that Analysis Services has implemented as its storage engine for a long time, 23 years now. And this same wonderful in-memory calculation and storage technology has also been borrowed by other product teams at Microsoft and implemented as capabilities like column store indexes in SQL Server. There are a few different ways to think about the way you would approach modeling your data. Categorically, we could think about bringing data from multiple sources into a flat model, meaning we simply combine that data together. And, you know, if you're a spreadsheet jockey, You're probably used to approaching data modeling this way, where you have some core fact data, and then you have some lookup tables, and you have some reference data. You bring all that together, you merge it together into one big giant table or spreadsheet, and that's what we would refer to as a flat model. And that's simple in many ways, but it's not always real flexible in different ways. And so that's option number one. There are products that promote flattened models. Think about a particular product that might be named after the French name for table. Again, not a bad thing, but you really have to think about extensibility and flexibility and scalability, and whether or not that will support additional features or additional requirements down the road. Option number two, master detail. This is the way we would typically model a non-dimensional database, a transactional database, where let's say you have orders and order details. So this is kind of an approach to normalizing data. We don't generally manage an entirely transactional database using a technology like Power BI or analysis services, but it might make sense to model tables in this way, where you have this summary or master table and then details that are related to that table. And then we have the dimensional model. Now, master detail and dimensional have some similarities, and we can combine those concepts, but this is a completely different approach. We're going to talk about that, so let's wait until we get there. All right. The world is not flat. Not always. Some people still believe it is. Let's look at a flattened view of the world and then think about how we can approach using that same data dimensionally. Now, this is a very simplified view for demonstration purposes. I'm going to take some common sales data. You've probably seen examples like this before in the AdventureWorks database or the Contoso database. It doesn't matter. I'm using the Contoso DW database, but everybody understands retail sales data, so that's what we're going to use as an example. So in this example, I have retail sales order records. Now, when you think about an order, what are the attributes of an order? Well, an order can have dates. There may be the date that it was ordered, the date that it was due, and then the date that it was actually delivered. So we have three columns here that represent different dates. They're events that occur relative to an order. Well, what else is part of an order? Well, maybe a customer. So a customer could have a company name, or maybe it's an individual person, so that person could have a name. In this example, we have the company name, and then we have a key that's actually used to look up a record in a source system, perhaps. Or maybe that's a generated key, a surrogate key that has been created in our data warehouse or a data mart. We also have product information. So here I have three separate columns that are related to products. We have the category of products. We have the subcategory that further describes products below the category, and then we actually have the product name. It could be other information like the color and the size and the weight, but in this example, I just have the categorization of products. Then I have three columns that are numeric, and so these are what I'm going to call my metrics, or the numeric columns that would be the base for my measures. These are typically numeric values that I'm going to aggregate in some way. We may sum them up, we might count them, we might take the min or the max or the average or the standard deviation, but some kind of aggregation will be applied to these columns. Now, this is just where it starts. This is the tip of the iceberg. So let's step back now and think about how we would approach this dimensionally. So, when we talk about dimensional models, we often use the analogy of a star. And that's because you can imagine that you have this fact table in the middle. A fact is, it's a business fact. Fact, an order has been placed. Fact, an order has been sent out for delivery. Fact, an order has been delivered. A customer has paid for the order. So that's a fact. That's a business fact, and that has those numeric columns that we're going to aggregate and do some kind of calculations against. We can describe facts using dimensional attributes. And those would be the product category or the product name or the date that the order was placed or the customer who placed the order. Those are dimensions, and dimensions have attributes. So we envision that these things are star-shaped. Whether they're 5 dimensions or 20 dimensions doesn't really matter. And in the real world, this is what a dimensional model might look like, surrounding, in this case, the online sales fact table. Now, a data model can have lots of facts. It could just be online sales, but it could be store sales. It could be inventory. Could be all kinds of things. All right, so where did these dimensional model crazy ideas come from? Well, there are lots of origins as database design evolved over the years. About 30 years ago, a group of people decided or discovered that dimensional modeling was a general best practice. We believe it to be a best practice today. Now, there are variations of dimensional modeling that have evolved since then, but dimensional modeling generally improves performance of a database and of queries in a database. It will give you more accurate results. There may be some exceptions to the rules of dimensional modeling. Now, 20 years ago, we didn't believe that. We said, these are the rules. You must always follow them. A lot of products that were built on top of dimensional modeling concepts enforced dimensional modeling rules strictly, and you had to create dimension tables, and you had to create keys, and you had to apply all of those rules. Today we realize that there are some exceptions, and sometimes it makes sense to round the corners a little bit and do things quickly and iteratively rather than taking all of the time necessary to fully flesh out all of your dimensions and keys and attributes and that kind of thing. You may not need a dimension table for every simple attribute. And so we may have a table that we see as a fact table, and it might have some dimensional attributes in it. Those are what we call degenerative dimensions when they just come out of the fact table. And you may or may not have to put that into a separate table. So who defined these dimensional modeling rules? Well, a lot of these concepts came from this group. About 30 years ago, a gentleman by the name of Ralph Kimball started a group called the Kimball Group. And this group of folks traveled the world, and they helped build data warehouses. They helped companies apply dimensional modeling rules, and they documented these rules. They wrote several books that are very well respected. And one of the books that is really kind of known as the Dimensional Modeling Bible is called the Data Warehouse Toolkit. And like the Bible, if we continue to use that analogy, it's an old book. And but it contains a lot of truths, and it contains a lot of concepts that most people in this industry believe to be the right way to approach modeling an analytical database. So I'd encourage you to go to the Kimball Group. What you'll discover there is that there's a simple method and approach to dimensional modeling, which includes, 1, selecting and understanding a business process. Maybe that business process is placing an order. How do we place an order? What information do we gather when an order is placed? And for reporting purposes, how do we describe and how are we going to build a dimensional model around that business process? Then you're going to declare the grain, the lowest level of data necessary to fulfill your reporting requirements. The level of grain might be a date. Maybe it's just the month level. We don't need to go down to the day level, certainly not the hour or the minute. And so we declare the grain and we say month is good enough. We're going to save some storage and improve performance by storing data at a monthly level. Is it at the individual SKU, the individual production line of a product, or is the product ID good enough, the product name good enough? That's the grain. Maybe it's just the product category. Is it the customer itself? Is it the individual person from a customer who placed the order? And again, that's what we mean by the grain. How low do we need to go across each of these dimensions? And then that determines what we're going to store in the fact tables. Then we identify all of the dimensions and the attributes of those dimensions, and then that helps us craft the facts. And this is a process that we typically go through in the past as we engineer an extract, transform, and load process, and then design a data warehouse. Now we can do all of that within Power BI as we craft our Power Queries, and then we can build the data model and then build relationships and calculations on top of them. Now, I'm not going to get into the details of all of the steps that the Kimball method prescribes, but it looks like this. We load detail at an atomic level. We do this according to the grain that we've already established. We structure dimensional models, and then we load fact tables at the same level of grain. And then we look at things like many-to-many relationships. We understand the cardinality, or the relationship between different tables. One-to-one, one-to-many, many-to-one, many-to-many, etc. And then we decide what we're going to use for keys, and in some cases we actually have to create our own surrogate keys. And I think an important point here is that this is an iterative process, and it's always going to be an iterative process. And as much as we would like to fully understand all of the business requirements up front and be able to have all of the technical requirements described for us so that we can build the perfect model, that has never happened in my experience in the past 25 years. It's always going to be an iterative process. All right, so let's take a look at our first example of a dimension table, and this is going to be a role-playing dimension. Now, what do we mean by role-playing? Role-playing simply means that we have a dimension table that's commonly used against one or more facts, and it simply needs to be materialized multiple times. So here's an example. This is a set of data that I commonly use as an example. Sometimes I just want to kind of get away from the retail sales examples that are so common, just for variety. And I use this set of data from the Bureau of Transportation Statistics. You can actually go to the BTS site. I believe it's bts.gov. And from the Bureau of Transportation Statistics, you can get a set of text files that represent all of the commercial airline flights in the United States and actually around the world. For every one of those flights, so think about a flight. We've all been on an airplane, we've all traveled by air, and you understand what a flight is, or what a segment of a flight is. And for each of those segments, you have an airplane that leaves an airport, and then that airplane arrives at an airport. It's a pretty simple concept. So a flight or a segment is a departure airport at a certain date and time, an airline, an airplane, all of the attributes of that flight, the flight number, etc. And then you have the arrival airport, and there are three-letter codes that are used throughout the world, and particularly in the United States, to represent these airports. Well, a departure airport is an arrival airport. I don't need to say, this uniquely describes departure airports, and this other thing uniquely describes arrival airports. But if I want to be able to select a departure airport and then select a departure airport, switch those around, then I'm really just going to use the same base table, but I need to materialize it twice because that's a role-playing dimension. We'll take a look at how that's actually done. Here's another very common example going back to our retail sales data. So if you look at my sales table, in this example, I have an order date and I have a ship date. And they're both dates, and we might be interested in the actual date that an order was placed and the date that an order was shipped, but we might want to step back and look at it by week or by month or by quarter or by year. So I'm going to need a date table to do that. It's very, very uncommon for a dimensional model to not have at least one date dimension table with one row per date. Now, you can see there's a little broken line here, and that suggests that Power BI will only allow you to have one active relationship between any two tables. Therefore, we must have multiple date tables. We simply materialize the same table based on the same query, in this case, 3 different times, one for the order date, one for the due date, and one for the delivery date. We're going to look at demonstrations using a date dimension. Now, as your model gets fleshed out and as it gets more complicated, then you may need, or you may not, need to use bidirectional filters. Now, bidirectional filters always have a performance cost. Here's an example of a bidirectional filter. From customer to product, I have sales in the middle. If I want to be able to select a customer and see the products that that customer has purchased, then my filter through these relationships must flow in a single direction. Naturally, it does not flow from sales to product. Therefore, if I want to select a customer and see their products bridged through this sales table, I would either need to have a bidirectional filter, or I would have to write a DAX-based measure that figures that out. And I'm going to show you an example. All right. Here's a more complex example. I'm not going to walk all the way through it, but this is actually in a real project that I built earlier this year based on COVID case data. We have our cases over here, and those cases can be recorded at the county level or the state or province level or at the country level. And because that geography is not the same as the population by country, I had to use this series of bridging tables to be able to associate my case details with my population by country table. Partially because the United Nations, who I got this data from, describe countries differently than the Centers for Disease Control and the World Health Organization, where the case details came from. And so, without getting into all the weeds, just know that these 2 bridging tables were necessary in order to model all of this data. And in order to select a country and have that give me population for population density and the COVID cases, I had to use bidirectional filters in order to approach it purely through the relationships in my dimensional model. All right, sometimes bidirectional filters are necessary, but not always. And if you're dealing with a lot of data and you're starting to see performance costs, there are other approaches. There are different ways to approach this. And there are also design limitations when you use bidirectional filters, particularly when you're applying row-level security. All right, many-to-many relationships. And we'll step off and we'll take a look at some demonstrations. Many-to-many relationships can be implemented a couple of different ways in Power BI. Now here's an example, just looking at a database schema of where a many-to-many relationship conceptually is necessary. So these are customer accounts, bank accounts. So we have customers in this table. We have transactions down here. Transactions are always associated with an account. Now an account can have multiple customers if it's a business account. And a customer can have multiple accounts. So I can't have a relationship directly between customer and account. So I need to have a bridging table. So this bridging table allows me to say this customer has multiple accounts. Potentially, and whether or not this is true doesn't matter, an account might be associated with multiple customers, and we can model that and we can materialize that just by populating these key pairs in this account customer bridge table. So if I want to select a customer and see the accounts and the transactions for those accounts, I've just dragged and dropped the key columns between these different tables. Let's look at the direction of this filter. So if I select a customer, you can see that through this one-to-many relationship, that's going to filter the account customer table. And the account customer table is not going to filter the account table because of the natural direction of this relationship filter from the many side to the one side. By default, naturally, That is not going to propagate that filter, and I'm not going to get a filtered list of accounts nor transactions. So, how do we fix that? The requirement, show me accounts and transactions for a customer. I can implement a bidirectional relationship. Now already I'm going to get in trouble with my Italian friends who are going to say, don't use bidirectional filters because there's a performance cost. Yes, there may be a performance cost, and this is a trade-off decision. I'm going to show you a way to do that. Okay. I just want to point out, I'm not going to read through this text. This is actually from a blog post that I wrote 6-7 months ago, where I talk about the approach that we take to modeling in Power BI. This is about half of the story. This is a whiteboard exercise that I will typically go through at the beginning of a project. 1, is the source data sufficiently clean and ready to be modeled? And the client's always going to say yes, and then we're going to discover that the answer is no, but that's question number 1. What is the data source? Is it a relational data source? If it's a relational data source, then I would typically advocate that we actually develop database objects such as views or user-defined functions so that we can encapsulate business logic and get better performance out of Power Query because it can do things like query folding. Then we're going to import from those tables, views, or user-defined functions, and then we're going to go through our dimensional modeling exercise. And this is really just going through the Kimball approach of figuring out the dimensions and the attributes and the keys and the relationships to the fact tables. And there's some very specific approaches that are a little out of scope for this discussion, but if you'd like to go back and look through the series of blog posts that I've written about using Power BI the right way, you'll kind of see my thoughts about this process. And then you're going to run into problems, and you're going to discover that there are more requirements, you're going to need some more data, you're going to need to add columns, that's going to get messy, and so you're going to end up repeating this process until we take it through the refiner's fire a few times, and then we flesh out this more elegant data model. All right. Disconnected tables. This will be my final topic before we get into some demonstrations. Sometimes it makes sense to add tables to your data model that don't have relationships. Now, why in the world would you do that? I mean, it's really all about relationships, isn't it? Well, yeah, kind of at a 101 level, yes, it is. But there may be opportunities to use a table just to drive a slicer or a filter so that we can essentially use that as a parameter and say, oh, the user selected this thing, or we're grouping by this value, and we're going to make some smart decisions based on that selection or grouping using DAX, using a calculation. And that would incorporate the switch statement or the DAX if function to be able to do that. Here's a quick example, and I'm going to use this as a step-off point to get to this demonstration. This selected measure period table, in this model, I actually just created by using the enter data feature. So I really just typed these values into a table. It's not stored in a source file or table anywhere because these are fairly static, and I can maintain this as the data model developer. And so if the user has selected the word current, I'm actually going to switch out this measure, and I'm going to return the value of a measure called store sales quantity. If the user has selected MTD, then I'm going to return store sales quantity MTD, etc. So you can see that I'm kind of playing this shell game with different measures that I've created. All right, let's take a look at some demonstrations. I'm going to start with a disconnected table and a dynamic measure. We're going to use a switched dynamic time series measure. And then I'm going to show you another example of a report on orders that are pending delivery. So let's take a look at this. This is a high-level view of my entire data model. Most of these tables were imported from the Contoso DW sample database in SQL Server. Don't worry, I'm going to zoom in. And let's switch over to another layout where I've just added 6 of the most relevant tables. As you can see, I have 2 fact tables, store sales and online sales. I have 3 copies of my date dimension table, order date, due date, and delivery date. You can see that online sales have 3 different dates. Store sales only have 1 date related to order date. And then store sales and online sales can both be related to a store. Online sales might be fulfilled out of a store. They might not be. So there won't always be a store associated with online sales. Now, I mentioned that we're going to talk about disconnected table. So keep in mind that I have these 3 role-playing date tables, and then I'm also going to take a look at my selected measure period table. Let's scoot over and we'll take a look at what's in that table. This table was simply created by using the enter data feature, and I just added these records. So let's switch over and take a look at the selected measure period. You can see it's a very simple table. It only has 6 values in it. So I have current, month to date, year to date, same period last year, prior year, and fiscal month to date. This table only serves the purpose of containing these descriptions. I need to know what they are in order to use them. And I do that first of all, by creating multiple measures. So I start with a very simple measure called online sales quantity. There it is right there. It's a very, very simple measure. And all we're really doing is we're taking the quantity field from the online sales fact table and we're summing it up. It's as simple as that. So let's take a look at this in a simple report page. So here I have a slicer so that I can just select a range of dates, and I've placed a matrix onto my report. So you can see that I've created a hierarchy called calendar hierarchy right here, which just consists of the year, month name, and date fields. Pretty simple stuff. And then I've dragged that hierarchy here into a matrix, and I've expanded that matrix. And if you scroll down, you can see the beginning of each of the months with the dates in the proper order. So let's just start by taking our online sales quantity measure and dropping that here into the matrix. And as you would expect, you see the aggregate values for the online sales quantity for each of the dates. There you see it by month, here you see it by year, etc. Pretty simple stuff. Now, I've created variations of this same measure called online sales quantity month to date, MTD, which we see right there. And I'm just using time intelligence functions like the total MTD against my online sales quantity measure, and then I reference the date table, which is a requirement for the total MTD function. I do the same thing with YTD. The code looks exactly the same, except I'm using total YTD, same period last year, uses the same period last year function. So I'm simply utilizing the time intelligence functions that are part of DAX. And so if I were to drag and drop the month to date variation, there you would see these same values, but you see that they accumulate over time, and then those accumulations reset at the beginning of each month. We would expect to see the same thing for year to date. The numbers are going to be the same in January, but then they're going to go up in February where the month to date numbers reset. Let's take a look at this in a graphical form. So here you can see the online sales quantity in this line chart. You can see that it goes up and down. And down here in this area chart, you can see that for 1 year, the year to date goes up. And then for each month it goes up and then it resets. And so that's kind of a visual confirmation that these time intelligence functions are doing what we expect them to do. Here you see the year to date for 2008, and then it resets in January, and then the year-to-date goes up again in 2009. Now, let's say that we want to do something a little more dynamic now. So I'm going to go back to my online sales quantity, and let's go ahead and remove all of my measures. Now I've created a table called selected measure period. We're going to make a slicer out of that, so I'll just drag and drop and turn that into a slicer just to keep things nice and simple. Let's move that around. We'll keep that as a list. But you can see I can choose from among any of these measure values. Now, I've also created a new measure that lets me dynamically play this shell game using the switch statement. And this is my online sales selected period measure. This is the one I was showing you on the slide just a few minutes ago. So using the selected measure period table, I can prompt my user to select a value. If current is selected, then I'm going to switch this value out and return online sales quantity, etc. Let's take a look at how this works. All right. First of all, I don't have anything selected, so we don't get a value back. I'm going to zoom in so that you can see this a little bit better. And if I click on current, you can see that this will now return the current value, just like we saw before. If rather than current, I choose month to date, then I'm going to see month to date values and so on. Okay, so this is great. Now my user can select any measure that they want, and they perceive that I just have this super measure that does whatever I tell it to do. Well, that's awesome. But what if I want to see these values side by side? Well, option one is that I could just drag the appropriate measure into different columns within a table or a matrix visual, or because I'm using a matrix that allows me to group on columns, I can drag and drop my selected measure period into the columns group of the matrix. Which then is going to enumerate all of the records in that table and will show me one column per measure name, and then the dynamic measure capabilities kick in, and it does all of the magic to show all of these values side by side. Let's say that prior year just doesn't make sense to show in this matrix because it repeats the same value over and over again. So what I could do is just select the measures that I want to see. Now, it's a fairly simple matter to place this visual on a report page along with other visuals, and there you can see a very interactive and well-crafted report page. All right. The next business requirement is online orders pending delivery. So these are orders that have been placed that have not yet been delivered. We want to know what the daily number of outstanding orders are. Now I can choose a range of dates, 7/24 through 10/7. I have 987 orders that on a daily basis were out for delivery but have not yet been delivered, or the orders have been placed. And then for each day in this column chart, you can see that there I have 892 orders on 8/14. Over here you can see that on 9/10 I had 888 orders. So how do we do this? Well, let's start by just taking a look at the measure, and then we'll talk about the mechanics of the data model that supports it. So it's a fairly simple measure. I'm essentially saying we need to select an effective date. So I'm declaring a variable here, And I'm utilizing another disconnected table called select effective date. And it's just a copy of my date dimension table that just has a date in it. And I just use that to select a date or to group by a date in this column chart. And based on that date, then we're going to do a calculation. We're taking a count of the rows in the online sales fact table. I'm overriding the filter context using the all function in online sales, and then I'm going to perform a filter. And there you can see the logic of that filter, where the order date is less than or equal to that selected effective date right here, and when the delivery date is greater than selected effective date. Now, I've done this or some similar measures in production solutions, and another thing that we would typically take into account is where the delivery date is blank as well, just to kind of extend this logic. All right, so it's pretty obvious what's going on here. I have a slicer where I can select a date, and then that's going to be applied. We're going to filter this column chart for every date in that range, and then the calculation is being performed for each and every day. So every column represents that calculation. But where's that selected effective date? Well, that is also a disconnected table. It's right there. It's a simple thing. It's just simply a list of dates. That looks like that. And if we go back and look at the data model, you would see that there are no relationships. Okay, it's just used for selection purposes. All right, this is another requirement that comes up in projects every once in a while. We have the ability to rank values, and we have the ability to be able to filter a list or filter a visual based on the top X ranking, but how can you do this dynamically? So that's the requirement that we're trying to fulfill right now. So as you can see, I have my total unit cost right here by category, and I want to be able to give the user the ability to say, I want to see my top 5 categories, or top 7, or top 9, or top whatever, top 25, top 50, top 100. So the first thing that we're going to do is we're going to rank them. And if you expand this, first of all, let's see this in action. There's my top 9 categories. Just trying to kind of do a hide and reveal thing here. So there's my top 9 categories. Here's my top 3 categories. So you can see that that's working the way that I want it to. So the first thing that we need to do is we need to rank them. I need to come up with a rank number. And I have an online sales quantity rank by category. This is a fairly simple piece of DAX code where I'm using the rank X function. The thing to know about rank X is that it does some internal rounding, and so it's really hard to do this with super fine precision. But it is a relatively simple thing just to call rank X and say, all right, well, based on the category name, just rank the online sales quantity, return an integer value that tells me what the rank order is. So that's pretty simple stuff. But I'm going to drive this now based on this disconnected slicer table, just like I did before. And I'm going to create another measure now that says, all right, based on a selection from that disconnected table, same pattern that we've applied before, if that has one value, then the selected value function is going to return that. And I'm just going to say if the online sales quantity ranked by category, that's that integer that you see in the right column there, if that is less than or equal to the selected value, then go ahead and return that value. Otherwise, return a blank. Why do I do that? Well, I do that because in this visual right here, I'm going to just set a filter and say the online quantity selected ranked by category, that measure is not blank. Simple enough. And that gives me this functionality. As you can see, a lot of these solutions are very simple once you figure them out. And that's, kind of the way life is. But that fulfills this particular requirement. All right. I'm just going to tease you with an advanced feature that I'm going to demonstrate after we introduce external tools. And this is an advanced feature called calculation groups. What is a calculation group? Well, we can get into the deep end of the pool and we can talk about some very advanced ways that we can apply this brand new feature in the Tabular engine. But we're going to start out by just saying that calculation groups are mo-better switches. In other words, it is a way that we can, in a very disciplined manner, a disciplined approach, apply the same pattern that I just demonstrated using a disconnected table and then a dynamic measure that switches out the values that are returned based on a selection. But we can do this by using this calculation group that can then be applied to different base measures in a large and more advanced designed data model. So stay tuned for that. We're going to show that once we introduce the Tabular Editor, which is a tool that's necessary to implement this because it is not yet a feature of Power BI Desktop. Again, advanced feature here. All right. Do you always need to create relationships? Now, I think that this topic gets filed under the learn the rules first. Once you know how to apply the rules and be able to accomplish and deliver on your requirements by correctly modeling your data, building the right relationships between tables, then you're prepared to break the rules. And by that, I mean that we don't always need to have relationships between tables in order to be able to use that table to perform calculations. So you can work outside of relationships to be able to give yourself more freedom. You may find that sometimes a relationship won't support the behavior that you're looking for, and so you need to work beyond just the constraints of relationships. And speaking of relationships, I thought it was apropos that the demo slide in the template that Past provided for us actually has Angela and Kellen, who are recognized members of the Past community and the MVP program. Who needs relationships? Let's take a look at how we can work without relationships in a Power BI data model. I'm going to show you an example of a pattern that can help you fulfill requirements that sometimes adhering strictly to the rules of modeling design can make it more difficult for you to fulfill. What do I mean by that? Well, I think there's a pattern in the world that goes something like this. When you're learning to do something new, like data modeling or dimensional modeling, you really need to learn to adhere to the rules first. And once you've completely learned all of the rules and exercised them and you understand them well, then you can step outside the rules and make exceptions and do more creative things. So here's an example. Here is obviously an interactive Power BI report. That is very much like the reports that we've seen. When I click on a visual, as you would expect, everything else on the report interacts with that visual. So I click on cell phones and everything just shows me cell phones. If I click on California, then all of the data is just related to sales in California, etc. It all works just like it's supposed to. So you would think, well, I must have a dimensional model behind this, and there are relationships between tables, and all of the filters are propagated between those tables. That's the way a Power BI data model works, right? Wrong. In this case, I have only one relationship in this model, I could probably have gotten rid of that relationship as well. So why in the world would I create a model with no relationships? And how can I expect anything at all to work? Well, it's done through the magic of DAX. And understanding how to use DAX and applying certain DAX functions is an important component of modeling. The model is the foundation upon which your calculations sit. So it's important to have your data correctly modeled first. But I can also create measures that don't rely on relationships. In fact, I can do a lot of creative things without relationships. So here's an example. Let's just take a look at my core measure inside this simplified model. And it's called online sales quantity. Notice what I'm doing here. Rather than just doing a calculate over the sum of online sales quantity, I'm using the treat_as function to say there are no existing relationships. Therefore, we need to go get the collection of customer keys. The values function creates a table with any customers that are selected. And then we apply that set of customer keys onto the fact table here. So essentially, I'm dynamically creating a relationship in my code. I do the same thing with my order date onto the fact table. I do the same thing with my product table onto the fact table. That's it. That's the whole thing. And I could do this with additional tables as well. A common question is there a performance cost? I believe that there might be slightly. However, in this small data model, we don't notice any performance difference at all between doing all of this in DAX and just building the relationships in a conventional model. All right, Power BI Desktop is a fantastic feature-laden tool. It's a great place to build most of your data models, your DAX measures, calculations, your visuals. Power BI Desktop really is that Swiss Army knife to build almost all of your model functionality and do your modeling. However, the Tabular modeling engine supports features and capabilities that as you kind of step off into a more advanced skill set, there are external tools that may be useful for taking you to the next level. And that's not to say that you can't always do what you need in Power BI Desktop, but Power BI Desktop was really designed to be a self-service analyst tool first. And a lot of the advanced capabilities that we have in SQL Server analysis services, using the Tabular modeling engine to do things like partitioning and calculation groups, and to be able to perform bulk operations or scripted operations against a complex data model, Power BI Desktop may not be the best tool for you to use to do that. And so this is a blog post that I wrote as the external tools feature was released in July of 2020, of this last year. So external tools is a new ribbon that shows up as of the July edition of Power BI Desktop. And if you have these tools installed, then they're going to light up on that menu. Now, you can build your own external tools. There are third parties and other people in the community who have created additional tools, and you're going to see that as I demonstrate external tools. So let's take a look at external tools. The External Tools ribbon in Power BI Desktop exposes third-party and tools that are not part of the Microsoft BI suite that will support Power BI Analysis Services, Tabular, and Azure Analysis Services. There were three tools that were available when the External Tools ribbon was made available in July of this year. The ALM Toolkit, DAX Studio, and Tabular Editor. These other tools are third-party developed, and there will be other tools in the future, of course. Now I'm going to open up Tabular Editor. This is a must-have tool for the enterprise business intelligence and analytics developer. Hands down, absolutely a necessary tool. There are capabilities in the Vertipack tabular engine within the platform that Power BI uses that are not exposed through Power BI Desktop, and this tool will expose them. So for example, if I want to define my own partitions, other than using the incremental refresh feature that's baked into Power BI, you can explicitly add partitions. So you can script those partitions, create your own partitions, and then deploy them to a premium workspace. Let's say that you have a set of measures that you want to rename, or you want to globally change within your PBIX file. You can do that. Let me find my measures table. I can just right click and I can duplicate a measure, or I can do a global search and replace, both within the code and within the name of the measure. The nice thing about Tabular Editor is that all of the changes that I make are just held in cache. They're not actually committed to the data model, which takes time. And then all of those changes, much like an analysis services project in Visual Studio, are all applied at the same time. It's a metadata change that's all committed to the model at the same time. Any changes that I make here, I simply click this button up at the top, and then that saves those changes back to the PBIX file within Power BI Desktop, and it's all kept in sync. It's a marvelous tool. Now I want to show you a feature that is not exposed in Power BI Desktop. This is a very advanced feature, and it's a feature that continues to evolve, but that is calculation groups. Now, we talked about using the switch with a disconnected table to build dynamic measures, but a very advanced application of that same concept can be had by creating a calculation group. Now, I've created a calculation group here that I call Time Intelligence, and you will see that that actually generated a table. So when I created this calculation group, it generated this table in my model. And when I add calculation items right here in the menu, I just give them names, and I'm able to essentially build a templated pattern for the way that time intelligence functions and other logic should be applied in DAX against different measures. This way, let's say I had half a dozen different fact tables, and I wanted to have the same time intelligence or the same dynamic measures that could be equally applied to the measures based on those fact tables. I use the selected measure function in DAX to apply logic to a measure that I'm going to programmatically select. Here's an example. Here is my month-to-date variation of a time intelligence measure. So I'm simply saying that for whatever measure I prescribe in my DAX code, I'm going to use the dates MTD function against a specific date table. It's the same pattern. It's a very simple pattern, but rather than explicitly naming a measure, I'm going to use the selected measure function, and then when I define a measure, I say this is the measure that I want to use. I can also implement a format string. In the interest of time, we need to pass on that. It's a large topic, and it warrants some more research on your part. Our friends in Italy at SQL BI have a whole series of blog posts and videos on doing calculation groups, and I'd recommend that you go there once you're ready to kind of wade into the deep end of the pool. This is an advanced topic. But suffice to say that Tabular Editor and these other external tools are a great addition to your Power BI desktop experience and necessary when you're building enterprise scale solutions. Composite models and direct query. When I started using Power BI, when it was originally introduced, I started teaching classes because I had been using analysis services for a long time, and then Power Pivot. And so Power BI really was kind of a natural extension of tools and technologies that I already had quite a bit of experience with. And I learned that, particularly in classes, as folks who came from a relational database background were introduced to BI reporting a la Power BI, they already had a skill set. They knew how to write SQL. They knew how to use SQL Server or Oracle or other relational database products. And there's a mindset there. So you think, if I need to get aggregate values out of my sales table, and I need customer information and data information and product information, well, we write SQL to do that. We already have those relationships and those tables that exist in our data mart or a data warehouse. So there's really no reason to import all of those tables and make copies into a Power BI data set. And so direct query seemed to be the right option to be able to solve a lot of those problems. And 9 times out of 10, it wasn't, because it wasn't as fast, didn't perform as well, and it didn't provide the flexibility and the extensibility that import mode does. And so I wasn't a big fan of direct query for that reason when it first came out. But after a period of time, I learned that direct query really had its place in the world. Now, what is direct query? Let's use SQL Server as an example, because that's the easiest example and one of the more common. So I just have a connection to my SQL Server, and I have a reference to my sales table, my product table, and my customer table, etc. As the user interacts with report visuals, charts, tables, matrices, rather than issuing a DAX query against the in-memory column store model, that query is actually translated into the native language of the data store, T-SQL in this case, and it runs a SQL query against the data source. And again, a DBA will look at this and think, oh my gosh, that's great. That's what we want to do, because SQL Server is the answer to all of our problems. However, the performance oftentimes is very, very poor. So there are reasons to use direct query. When you need up to the minute, up to the second results directly from a data store, direct query may be the right thing to do. If you have extremely large tables that would be difficult to read into an in-memory model, and I will add that that is exceptional, that generally speaking, we can load a lot of data into an in-memory model. Again, direct query might be a good choice. We'll enter composite models. Now, this is a capability we've actually had for a little while now, a couple of years. And the idea behind a composite model is that some of my tables can be in memory, so they're fast, and the entire set of DAX functions will work against them. I can do a lot of cool things in DAX with measures. And then a select few tables can be direct query. Let me say this, that 98% of your models should be in import mode. Direct query is generally an exception, and I think it is yet another example of something that you should do after you learn to run with model design in Power BI, rather than the first thing that you do as you're learning to create models. In this last demonstration, we're going to use direct query in a composite model to be able to get customer details from the data source that are up to date. We don't need to reload data or refresh data in our data model to be able to get those details. Now, again, there are trade-offs when using direct query, but for this kind of detail reporting, it may be very appropriate. The scenario is that I have customer details that are changing all the time, and it's important that when I select a customer, that I'm able to get to those details without having to reload data. In this report page, you can see that I can get customer in this report page, you can see that I can get customer summary information by city. So these are all of my customers in Hamburg. I have 115 customers there. There are the customer names with some summary information. Here's a list of my customers in Berlin. Let's say that I would like to go take a look at Kristen's up-to-date information. So I have a drill-through report. And I have not yet run a live query against my source database yet. Everything you've seen so far has been in memory in my data model. But when I drill through, that's going to take me to a page that is based on a direct query. And now I'm seeing this live data. So this is actually information that's coming directly out of my SQL Server database. It could be through my gateway or it could be Azure SQL, but this is coming from the data source. And this query that returns this information had not previously been run. Okay, how does that work? I had imported my customer information in two different ways. I imported summary information. This actually came from my customer table in our simple database, but I only imported the data that I needed, only the columns that I needed. But I also imported the customer information in another table, and when I chose Get Data, rather than using the import mode, I used direct query. So I put in my server, my database, and I chose direct query. And that creates this query definition that then describes this table, but there's no data sitting in my data model. It's just a connection out to that table. The rest was just report design. So this is a drill through report that I added some filtering fields into, which then made it available to drill through into. And now when I right click on any customer record or any other visual that contains those fields, I have the option to drill through. So use direct query sparingly, use it when it only makes sense. But it's a great way to be able to get to live data when you don't need to do a lot of heavy DAX calculations to summarize and aggregate that data. As you can see, using composite models with import mode and direct query mixed in the same model gives us a lot of flexibility. But you also have to use these capabilities very carefully and plan cautiously. But wait, there's more. So as the concept of composite models matures, the product team have been working on the Gen 2 version of composite models for several years now. It's been in incubation internally for a long, long time. A lot of that activity has been under NDA. It was the plan was released as part of the Wave 2 roadmap of Power BI. And we know that this feature is coming. What is this feature exactly? So things are about to get really interesting. I want to look at this graphic and say, when this baby hits 88 miles per hour, can't finish that sentence. Power BI 2020 release Wave 2. This month, we are going to see some new preview features. And this will probably be in preview for quite some time because we're talking about a very significant architectural upgrade of the Vertipack engine, of Power BI data sets in premium, of analysis services, Tabular, that now gives us the ability to create composite models over Power BI data sets and Azure Analysis Services. What does that mean exactly? Well, here's a scenario. Dataset 1, deployed to a workspace, contains a set of tables, and we have another data set over here, and maybe that's an Analysis Services tabular model. So this is a Power BI data set, this is an Analysis Services model in Azure, and I now want to create another data model that contains some of the tables from dataset A, some of the tables from dataset B. Rather than importing that data again, I use direct query to simply reference tables in each of those models. In 2 models, maybe a 3rd model. Essentially, I'm going to build this super data model over the top of these already deployed data models, and I'm able to surface only that metadata, and then users can browse that, and I can build reports against that superset of all of those established data models. The possibilities are pretty limitless. Now, we've been seeing demonstrations. The product team have been talking about this for a long, long time. We need to kind of walk before we can run. But I think we're going to see some really, really interesting, really, really strong capabilities coming out in the next few months. And time will tell. It's going to take time to figure out exactly how to tame and manage this thing. But the bar just got raised very, very high. And there are some great things that are coming. All right. If you download the deck, you can go out and you can read about Wave 2, or you can search for this. It's in Microsoft Docs. 2020 Wave 2 is what you're looking for. And cool stuff coming. Well, with that, let me wrap this up just by pimping the blog, just by promoting a blog series that I've been working on over the past few months this year called Doing Power BI the Right Way. So started working on this in early July. I've got 8 posts in the series out there so far. I'm really looking for feedback and comments. And then based on those questions, feedback, comments, and just the input from the community, I'm working on additional blog posts, but my objective with this series of blog posts is to be able to put together my best practice list, my list of suggested patterns for building proper BI solutions according to my rules, which are essentially the rules and the patterns that I apply when I build solutions. And as I've worked with my colleagues at 3Cloud and Pragmatic Works over the years, and other people in the industry who really focus on building scalable and properly crafted data models. So please visit my blog and provide your comments and your input. And I hope to see you out there in the community. So these are some resources for you. Please feel free to look these up. You're welcome to reach out to me and connect with me via these connections in Twitter, in LinkedIn, and of course on my blog. And with that, we're going to have a Q&A session now. So we'll go ahead and wrap up, and I'll take your questions. So with that, thank you very much for your time and attention.